Section 1.2, example 1.8. Use geometric formulas to calculate the definite integrals. So use a formula for the area of a circle to evaluate from 3 to 6 of the square root of 9 minus x minus 3 squared. They mentioned the area of a circle. Sounds a bit weird. Oh, I see it. So if you guys remember from the conic section, this kind of looks familiar. Let's try to break that part down. So here we have, we'll say y is equal to the square root of 9 minus x minus 3 squared dx. That's part of the calculus part. So let's put our algebra hats on really quick. In order to make it look a little bit more like a circle, let's square both sides. So we're left with y squared is equal to 9 minus x minus 3 squared. Let's get our x's, our love, anything with a variable over to the left side. I'm still going to kind of keep it the same though. Y squared plus our x minus 3 squared equals 9. That looks really familiar, but I think we could do a little bit better. Let's switch the two. X minus 3 squared plus y squared equals 9. Oh my goodness. So this here is a circle. So that's a circle centered at, so opposite of h and k, so 3, 0. So center at 3, 0, and with a radius. The square root of 9 is 3, so radius equal to 3. Or you could think of it the square root of 9, which is 3. All right, so a circle. Let's draw the whole thing just so we could kind of see what's going on here. So 1, 2, 3. All right, so the whole circle, we have 1, 2, 3. We go up 1, 2, 3, down 1, 2, 3, and 1, 2, 3. So here's our circle. Again, I want to add, I'm not an artist, so I know this might not look like a circle, but for the meantime, it will be. All right, so now let's start chopping some stuff off. Because over here, in order for it to be a function, like it doesn't pass our function stuff here, right? So in order for it to be a function, this tells us that we're looking at the positive part of our graph. So we're looking at this top half right here. So what I'm going to do is put this in gray so we could kind of ignore it. Oh, that's a little bit too much. So ignoring this part, it is still important to the graph, but not really right now. All right, so that's our function. Oh, another restriction, we're only looking at the values from 3 to 6. So we have 1, 2, 3. So starting right here and ending 4, 5, 6. So we're just looking at that part. So again, we're ignoring the bottom part. We're only looking from 3 to 6. So we're ignoring this part too. So let's look at exactly what we're looking at. So we're looking, oh, right here. We're looking from 3 to 6. We're looking at only the top half and the right part of the graph. So we're only, highlight it. So we're only looking at this part of the circle, which just so happens to be exactly 1/4 of the circle. So top half, right half, only parts that overlap. There we go. So what we could think of here, or what we could solve this with, is with the area of a circle. So area of the circle . So for area of the circle, it's equal to pi r squared. Now area of this circle, so for this problem, what we're looking at is the area of 1/4 of that square. So 1/4 pi r is 3. So that's what we looked at earlier. 3 squared. So that ends up being 9/4 pi. We could leave it like that, but you know what? We're experts here. 9/4, and we're multiplying by pi. So 7.06858. So 6. And there we go. That is the solution. All done. Super easy. If you happen to have any questions, please feel free to ask. Otherwise, bye.